name is Owen Mason, and this is my Physics 2211 Lab 3 video. This lab, we are analyzing the centripetal force and orbits of a star around a black hole. Also, we are tracking the motion of a spaceship and planet orbiting a black hole and the two objects interacting with each other. We also have to calculate the mass of the black hole from the trajectory of the star, and we also have to determine the initial speeds of the spaceship so it wouldn't crash into the planet or black hole, but also will travel close to the black hole and escape from it. In this lab, we are utilizing Newton's second law along with gravitational force and centripetal force. Centripetal force also acts in multiple dimensions, one in the parallel to its motion and the other perpendicular. Lab, we are analyzing the motion of a star around a black hole, and we also will calculate the black hole's mass from the star's trajectory and speeds. In the GlowScript code, we calculated the initial momentum and the final momentum of the object, and using this, we were able to isolate the perpendicular and parallel momentums and forces of the object. Using these forces, and using the position updating formula in Newton's second law, we are able to calculate the object's speed and position as it travels. Using this, we were able to calculate the star's mass using gravitational force equation. The average mass calculated of the black hole was 1.54578 times 10 to the 34th kilograms. And this is the perpendicular and parallel forces acting on the ball, and along with the net force acting on the ball on the star as it travels in a circular orbit around the black hole. Seeing how a spaceship, a planet, and the black hole all interact with each other as they all travel in circular paths around each other. In this part, we are analyzing GlowScript. We calculated the net force of the forces acting on the planet, which are the gravitational forces of the black hole, and along with the gravitational forces and the gravitational force of the ship acting on the planet. And we also calculated the net force on the ship. We calculated the net force of the black hole on the ship and the net force of the planet on the ship using the gravitational equations shown earlier. Using the net forces, we were able to calculate and update the position of the planet as it travels in an orbit around the black hole, and also calculate the updating position and velocity of the ship as it travels toward the black hole and then eventually escapes from the black hole's orbit. Using this code, we generated this formula, this image. The pink is the path of the ship as it travels close to the black hole and eventually escapes from the orbit. The blue is the path of the planet. As you can see, it's starting to travel in a circular path around the black hole. As you can see in part 1, the perpendicular and parallel forces both differ from the momentum arrow. This is because the parallel and perpendicular forces combine to equal the net force and the current momentum of the star as it travels in a circular orbit around the black hole. The ship to, instead of traveling close to the black hole and escape in orbit, what if we wanted the ship to orbit around the black hole and not crash into the planet or the black hole? For the object to stay in orbit, I used trial and error to figure out an initial velocities to stay in continuous orbit without crashing. To calculate the speed of an object to orbit, if only one body was acting on it, we would use the equation below, which you can calculate by setting centripetal equal to gravitational force.